Welcome to G Fun Facts Online, the show that digs deep into the science behind our world. Today, we're going deeper than ever before, literally. Imagine a fortress, a command center, or a top-secret facility buried under hundreds of feet of soil, rock, and reinforced concrete. How do you reach a secret that's been so deliberately hidden? You don't knock on the door. You create a man-made earthquake. You use a weapon known as a bunker buster. In a world where power is often buried, these munitions are the keys to unlocking the deepest, most fortified secrets on the planet. They are not just bombs. They are a masterclass in physics, engineering, and sheer brute force. So join me today as we explore the incredible science of how to break into the world's toughest safes, the bunker busters. Let's start with the basics. Because at its heart, a bunker buster is a beautiful, if terrifying, demonstration of one of the simplest rules in physics, kinetic energy. You might remember it from high school science class. It's the energy an object has because of its motion. The faster it moves and the heavier it is, the more kinetic energy it has. A bunker buster is designed to be the ultimate embodiment of this rule. Picture a giant, cosmic hammer driving a massive nail into the earth. That's essentially what's happening. A stealth bomber, like the B-2 Spirit, flies to an altitude of around 39,000 feet. That's 12 kilometers straight up. From that height, it releases the bomb. For the next minute or so, gravity takes over. The bomb is just falling, but as it falls, it's accelerating, picking up tremendous speed. It's converting all that potential energy it had from being so high up into the raw, burrowing power of kinetic energy. When this massive speeding object finally hits the ground, all of that energy is focused onto the tiny point of its nose. It doesn't just explode on the surface. It uses its own momentum to carve its way through anything in its path: soil, clay, rock, and multiple layers of concrete. It's physics at its most forceful. So what makes these things so good at their job? Let's dissect one of these penetrators. It all starts with the casing. The shell of a bunker buster is its most important feature. It has to be incredibly strong to survive the impact, and incredibly heavy to build up that kinetic energy. History gives us a fantastic example of this. During the 1991 Gulf War, the US military needed a deep penetrating bomb, and they needed it fast. In a brilliant feat of battlefield engineering, they took surplus 8-inch artillery barrels, which are made of hardened steel, designed to withstand constant explosions, filled them with explosives, and turned them into the first GBU-28 bunker busters. They literally repurposed cannon barrels into bombs. Modern bunker busters use even more advanced materials. The current champion is the GBU-57, also known as the Massive Ordnance Penetrator, or MOP. This thing weighs 30,000 pounds, or over 13,000 kilograms. For perspective, that's the weight of 2 large elephants. The vast majority of that weight is just its high-performance steel alloy casing. All that mass is there for one reason: to generate the unbelievable kinetic energy needed to shatter hardened targets. Some designs have even used exotic materials like depleted uranium, which is far denser than steel, to pack more weight into a smaller package. Next, you have the shape. A bunker buster looks like a giant dart. It's long, narrow, and aerodynamic. This shape is crucial. The narrow profile means it has to push less material out of the way as it burrows into the ground, making penetration easier. The aerodynamic design, complete with tail fins, keeps it stable during its high-speed fall, ensuring it hits its target precisely. Some of the earliest bunker busters from World War II, like the British Tallboy bomb, even had fins that were slightly offset. This made the bomb spin as it fell, creating a gyroscopic effect that made it even more accurate and less likely to be deflected by whatever it hit. Finally, after all that focus on getting deep underground, there's the payload. The ultimate goal is to deliver an explosion. This is usually a high-explosive mix, like tritonal, which is a blend of TNT and aluminum powder. The aluminum powder enhances the blast, making it faster and more powerful, which is better for shattering underground structures. But here's the fascinating part. In a 30,000-pound GBU-57 bomb, the explosive payload is only about 5,000 pounds. The other 25,000 pounds is almost all solid steel casing. The penetration is so important that the bomb itself is mostly just a giant, heavy dart with an explosive afterthought. Okay, so the bomb has fallen from the sky, it's pierced the surface, and it's tunneling deep into the earth. What happens next is a sequence of precisely engineered events. A modern weapon like the GBU-57 can reportedly penetrate up to 200 feet of earth and concrete before it detonates. Some estimates suggest it can defeat 20 feet of solid reinforced concrete. And there's an even more devastating tactic called burrowing. This is where you drop multiple bombs on the exact same spot. The first bomb hits, penetrates, and detonates, creating a deep crater and fracturing all the material below it. Then, a second bomb is guided into that exact same hole. It uses its kinetic energy to push even deeper before it explodes, effectively drilling its way down to targets buried at extreme depths. But none of this would work if the bomb just exploded on impact. The secret ingredient is the fuzz, the tiny mechanism that tells the bomb when to detonate. Early versions just used simple time delays. Modern fuzzes, however, are technological marvels. These smart fuzzes have sensors called accelerometers. They measure the g-forces as the bomb smashes through different layers. This allows the fuse to literally count how many concrete floors of a building it has passed through. They can also have void sensing capabilities. The fuse can detect when the bomb has passed through a solid layer and entered an empty space, like a room inside a bunker. This allows it to detonate the warhead at the precise point where it will do the most damage, inside the target itself. Planners can program these fuzzes to go off at a specific depth, or after a specific amount of time, giving them total control. And when it finally detonates deep underground, something incredible happens. The explosive energy is coupled with the ground. Instead of dissipating into the air like a surface explosion, the blast is contained. It creates a powerful seismic shockwave that travels through the earth, collapsing tunnels and crushing underground structures far more effectively. This is why the first bunker busters in World War II were nicknamed earthquake bombs. The evolution of these weapons is a story of escalating challenges and brilliant responses. The concept was pioneered during World War II by the British engineer Barnes Wallis. His Tallboy and Grand Slam bombs were designed to defeat hardened Nazi submarine pens, not by hitting them directly, but by landing nearby and creating a miniature earthquake to collapse them. The modern era of bunker busters was born out of necessity during the 1991 Gulf War. The rapid 28-day development of the GBU-28 laser-guided bomb to strike Saddam Hussein's deeply buried command bunkers proved the value of these precision-guided penetrators. Today, we have the apex predator, the GBU-57 Massive Ordnance Penetrator. It was developed specifically to counter the most deeply buried and hardened targets imaginable, like those believed to exist in countries like North Korea or Iran. It's so massive that only the B-2 stealth bomber can carry it, and it can carry two of them. It's a weapon of truly strategic importance. But there is one final, unspoken option when it comes to busting bunkers. The concept has also been applied to nuclear weapons. A nuclear bunker buster, like the B-6111, is designed to penetrate the Earth before detonating. The idea is that a subsurface nuclear blast would transmit a huge amount of its energy into the ground, creating a seismic shock capable of destroying even the most super-hardened facilities that are built to survive a surface nuclear attack. But these weapons are highly controversial. Critics worry about the immense amount of radioactive fallout that would be thrown out of the crater, and they argue that using one would dangerously blur the line between conventional and nuclear war. From the simple physics of a falling object to the advanced materials science and smart electronics of today, bunker buster bombs have fundamentally changed modern warfare. They are a powerful reminder that in the timeless contest between building a stronger shield and forging a sharper sword, physics, when expertly applied, can provide a key to unlock any door, no matter how deeply it's buried. That's all the time we have for today on Fun Facts Online. Thanks for listening.